Excuse me. Hi. Hello. Thanks for thanks for arriving early. We will start our live stream today at 4 p.m. You wouldn't want to miss this one because there's a lot of very useful tips in this lesson. All right, so we have 2 minutes left before we start our problem solving live stream today. So please get your handouts ready. Okay, and then we will go through some very classic modeling and age problems today. Right? Hi, everybody. I see some familiar names. Thank you for telling me who you are. Okay. Hopefully, your week has been splendid up to now. Okay. And hopefully, you have been using the all-in-one guide, or rather the master book, to do your revision and practice for the upcoming Sasmo. Hi. Okay, 1 more minute until we start. All right, everyone, get ready. Get your handouts ready. If you don't have your handouts, it's okay, right? You can use a piece of blank paper and follow around as well, right? Follow along as well. Okay, so yeah, modeling and age problems. I believe all our students should have learned with us. Okay, so today I will go a bit further and explain some tips and tricks when solving these sort of problems, right? Depending on the question. Anyway, now that it's already 4 p.m., right, let's get started with our live stream today. Lots of useful tips and tricks, okay, as well as a very important review on modeling. Okay, so hello everybody, this is Teacher Yonglam. Welcome to our P3 Sasmo key topics live stream too. Very happy to see so many people coming here today. All right, so with that, let's get started. Okay, so today it's our second live stream. Okay, hopefully you still remember. You do, right? Because you're here. Every Thursday, 4 to 5 p.m. in January, we will meet here either on WeChat or YouTube, okay, where I will share useful tips and tricks in solving common Sasmo topics, problems. Okay, so with that being said, hopefully you have all collected your master book, okay, which contains the real past year papers and also the master book with targeted practice for different knowledge points based on the real Sasmo papers. Okay, and today we'll be focusing on modeling and age problems, right? This is in your book B, topics 25 to 31, right? All related to bar models, okay? With that being said, let me adjust the pen size, okay? You might see, hey, teacher, there are not that many age problems and modeling problems up to now, right? Because you see in 2020 to 2023, it doesn't appear that much. But look what happened in 2024 and 2025. It seems that it has started to appear more and more frequently, right? 2 questions in each year. And also, right, the questions itself is getting more and more complicated, more and more challenging. They will not give you the key points to the questions directly. Rather, they will appear in a more subtle, indirect way. So today, we will first do some review questions, okay? And then we will work on these tips and tricks, right? These indirect hints to help solve modeling questions, right? So first of all, let's get a speed run going, okay? Why is there a 40 here? I don't know. Hide it first. Let's read the question. Okay, so get your handouts ready. We are going to do 3 rounds of model drawing speed run, right? You should have known all of these knowledge by now. Let's get started. There are 128 eggs in 2 baskets altogether. The smaller basket has 40 fewer eggs than the bigger basket. So in that case, how many eggs are there in each basket? So here, there are 2 key numbers given to you. Anyone can tell me what they mean? Right, 128 eggs altogether. What type of information is this? Is this the difference? Is it a multiple? What do you think? Right, altogether means this is the sum or this is the total. Right, so in total we have 128 eggs. Okay, and then we also have smaller basket is 40 fewer eggs compared to the bigger basket. Whenever you see a number more or a number less, a number fewer, this number 40 here, for example, it refers to the difference, right, of the 2 items. So actually, we are talking about a sum and difference problem here. And to solve a sum and difference problem, we will draw a bar model. Okay, so let's start off by labeling the names. What are we comparing? We are comparing the big and the small basket. So you write out the names, and then before drawing their bars, please also draw a starting line. You have to make sure the bars are starting from the same point or the same starting point. Okay, so then we will draw the bars now. Now, which bar should be longer, right? Should I have a longer bar for the smaller basket or the longer bar for a bigger basket? That's right, it should be a longer bar for the, longer bar for the small or big. Right, we should have a longer bar for the bigger basket and a shorter bar for the smaller basket, right? Because the thing that has less, you draw a shorter bar. More, longer bar. Okay, and then with that, we want to label the sum and the difference, right? The sum and the difference. To label the difference, first draw a dotted line, right? To separate the common part and the part that only appears in one of the bars. Then you label the difference is 40. Then the sum or the total combines everything, right? So then this sum is 128. With that, how do you find the number of eggs in each basket? Okay, so you see, are both of them the same? No, how can I make them the same? Let me remove the extra 40 first. Right, so 128 minus 40 equals to 88. Okay, but that doesn't mean that this is 88, this is 88. You know, 2 bars add up together will be 88. And they are referring to the same number now because I take away the difference. So that it's 88 divided by 2 equals to 44. Right, so that means each of the bars or each of the common parts here is a 44. But don't forget there is a 40 that is extra for the bigger basket. So with that, how many eggs are there in the small basket? Now refer to the bar model after you label. There are 44 such eggs. And for the big baskets, there is 44 plus 40. Don't forget the difference. Okay, 44 plus 40 is 84 eggs. Okay, and then to check your answer, you can use the sum as well, right? 44 plus 84, is it 128? It is, right? So after doing these problems, make sure you check your answer by checking with the given information. Is the difference correct? Is the sum correct? Okay, so this is a sum and difference problem. Is everyone doing okay? Everyone, all good, huh? Yes, very good job. Okay, so with that, we have looked at sum and difference. Let's take a look at the next type of question here. Right, there are 28 eggs in 2 baskets altogether. Again, altogether, so this is the sum or the total. But now, I'm telling you, the bigger basket has 3 times as many eggs as the smaller basket. So this time I tell you 3 times, right? It's actually a what type of relationship? Not the sum, not the difference. It is the multiple relationship, right? It's a multiple relationship. And now, how many eggs are there in each basket? Now, this is a sum and multiple question. Whenever you see a multiple relationship, the way you draw the bars should be a bit different, right? What is the word that you always think of? Right, remember, when teacher Yonglam is in class, when I see a sum and multiple question, I will always ask, what is my one unit? Right, so in this question, is the bigger basket my 1 unit or the smaller basket my 1 unit? Bigger 1 unit or smaller 1 unit? You're not done yet. It's okay, right? The notes will be sent later. So for now, most importantly, listen to me carefully, right? I'll send the notes in the group later, all right? So you can see that the smaller basket has less eggs than the bigger basket. So I will label the names as usual, big and small, but then the small basket is my 1 unit because it has less eggs, right? So then I will label the small basket with 1 unit, that is 1 bar. Okay, so one such bar, one such box for the smaller basket. Then how many such boxes should I draw for the big basket? Right, like I said, if my small basket is 1 unit, big basket is 3 times. 3 times, so it is 3 units, right? So you draw the same bar, 1, 2, 3, 3 times. Okay, and now what else do we know? We also know the sum, right? The total. So we need to label the sum out, right? The sum is 128. So altogether, the total is 128. So what we do now is to find out what is the value of 1 unit, right? What is the value of 1 unit? Right, like I said, it's okay if you couldn't get to finish it. Listen carefully. That's the most important thing because today we are jam-packed with a lot of useful information. Right, so then you know that how many units are there in total in my 128? It is 1, 2, 3, 4. 4 units. So actually we know 4 units is equal to 128. Then 1 unit, how do you find it? 4 same units is 128. So 1 unit is 128 divided by 4 equals 32, right? 32. So 1 unit is 32. So every box here is a 32, 32, 32, 32. With that being, with that being said, can you find out how many eggs are there in the small basket? How many eggs are there in the big basket? Right. So let's look at the small basket first. The small basket only has 1 unit. We know 1 unit is 32. So then the small basket has 32. The big basket, however, has 3 units, right? It has 3 units. So these 3 units, 3 times 32, right? Every 1 unit is the same. 3 times 32, 96. So there are 96 eggs in the big basket. All right. So with that, that is how you attempt this question, sum and multiple. Whenever you see a multiple relationship, you need to think how many units, right, is each of the characters. All right, so this is a sum and multiple question. Now let's move on to the next question. Let's see if you realize what are the information here. Okay, we see that a big basket has 128 more eggs than a small basket. 128 more. Can you tell me what type of information is this? Is this 128 still my sum? Is it still my sum? No, right? 128 more. We are comparing the difference between these two baskets. So this time, 128 is my difference. And I also told you the big basket has 5 times as many eggs as the small basket. So this 5 is still my multiple relationship. Whenever you see a multiple relationship, you know you need to look at it and draw the model based on the multiple relationship first. Now, how many eggs are in each basket, respectively? So likewise, we are comparing the big and the small. Right? Can you find out who is the 1 unit over here? What's the 1 unit? Big basket is 5 times as many as the small basket. So the small basket is 1 unit, and the big basket is how many units? 5 times, right? 5 times. So it should be 5 units. 1, 2, 3, 4, 5. 5 units. Okay. So first, label out the multiple relationship. Okay. After you label up the multiple relationship, we now need to find out the, that's right, we need to find out the difference, right? 128 more eggs. So where is the more part? Remember, for the difference, you draw a dotted line first. Separate the part where it's the same versus the part that appears in only 1 bar. So these 4 units is my difference, and I know it is 128. Right? Label the difference properly. Right? Your brackets should be drawn neatly, and then you will find out 4 units is equal to 128, right? And then now you also know 1 unit is 128 divided by 4, which we already calculated just now. What is it? It is 32, correct? 32. Okay, so every unit is a 32. Okay, so we've said how many eggs are there in a big basket? Now remember that we count the number of units for the big basket just now. Wow, Dora, got so many nice answers. Very good. We have 5 units, 1, 2, 3, 4, 5. So 5 times 32. And you can do your calculation. I trust that you are able to do it. 160. All right. As for the small basket, because it only has 1 unit, right? 1 unit here, we know it is 32, right? Then you can check the difference. 160 minus 32. Is it 128? If it is, good, you are correct. All right, so this is a review of the 3 types of sum, difference, multiple question. Sum and difference, sum and multiple, difference and multiple. Now, the next part is where things get juicy, right? The real important part. Just now, everything we do is just warm up. Now, I'm going to show you some key types of questions that often appear in Sasmo. What are the concepts that you need to know when you are doing these questions? Okay, with that, here's the key point from the warm-up just now. When the question gives you the total, which is the sum, the difference, and the multiple relationship, at least 2 of it, sum and difference, sum and multiple, difference and multiple, you will use bar model to solve it. Okay, this is the key point for today, the first key point. All right, and with that, now let's take a look at another warm-up. Now, here is where we will start talking about the different tips and tricks, starting from the first question. There are altogether 57 pens, rulers, and erasers in a box. Right? Pens, rulers, and erasers. There are 3 fewer pens than rulers. There are 6 more erasers than pens. Please order the types of stationery from the least to the most. Oh, I need to change the question a bit. I guess I mean from the most to the least. Okay, from the most to the least. Okay, now what is different about this question? Previously in our warm-up, how many things are we comparing? I'm always comparing the big basket and the small basket. But today, in this question, there are 3 types of stationery: pens, rulers, and erasers. And I gave you the sum, right? And I gave you the difference. So if I have more than 2 types, maybe 3, maybe 4, how do I compare the number of items for each type? Right, so here there are actually 2 pieces of information to help us. There are 3 fewer pens than rulers, so this is the difference between the pens and the rulers. There are 6 more erasers than pens, another difference. So we need to first find out how to draw the model, right? How long or how short is each bar? So we need to compare who is more and who is less. To do that, what is the tool that we use? What is the tool that we use? Stop spamming, okay? So answer me, what tool do we use? We use a magic arrow or a number line, right? To arrange the items from the less to the more, right? Which is less, which is more. So let's read each of the hint and fill them in on the magic arrow. Remember, right side is more, left side is less. Now there are 3 fewer pens than rulers. So pens is here. Should I put rulers to the left or to the right? Should I put rulers to the left or to the right? Pens is fewer, so the ruler is on the right. Ruler is more, pen is fewer. So you follow less on the left, more on the right. Then you label the difference. This is a 3. Also, there are 6 more erasers than pens. Wow, eraser is also more than pens. So erasers more than pens. It should be on the right. But then, should I put eraser here, A, or eraser here, B? What do you think? Would you put the eraser at A or B? It's more than pens, of course. I put it on the right, but would you put it at A or B? A or B? That's right, you put it at B. Here's the reason why. Right, good job, everybody. Why is it B? That's because, you see, ruler and pen, 3 fewer. So the difference here is only 3. But between pens and erasers, you see that the difference is 6. It's a longer difference. It's a bigger difference. So that's why the gap between them must be longer as well. So erasers is here. So I can draw this difference and label them with a 6. Okay, so with that, now we can say from the most to the least, look more to less. Erasers come first, then rulers, finally pens. Okay, eraser, ruler, pen. Okay, so when you see 3 or more quantities and you want to compare which one is more, which one is less, please use a magic arrow. Okay, now with that, let's apply what we have learned on this question. Right, let's read the question and find the keywords. It's on your handout, by the way. In a classroom, Kevin wrote 30 more letters than Sarah. Kevin, 30 more than Sarah. And James wrote 40 more letters than Sarah. Altogether, they wrote 160 letters. We want to find the letters Kevin wrote. Now, over here, you see that we have some numbers, right? 30 more letters. So this 30 more is a difference. 40 more. 40 is also a difference. Now, what about 160? Is it a difference? 160, is it a difference? Altogether, right? When you see the word altogether, you know it is referring to the sum or the total. So this is a sum and difference question. There's longer bars and shorter bars. But whose bar is long? Whose bar is short? You see over here, I have Kevin. Now, let me change my color. Kevin, Sarah, James. 3 people. We have 3 quantities to compare. When we have 3 quantities, please draw a magic arrow to compare them. Right, again, less side on the left, more side on the right. Now let's try to plant the people on this arrow to compare who has more and who has less. Now let's read the first sentence. Kevin wrote 30 more letters than Sarah. Now can you answer me? Sarah Kevin or Kevin Sarah? Who should be on the left? Who should be on the right? Okay, maybe I just ask. Is Sarah on the left or Kevin on the left? Who is on the left? Faster. Is Sarah on the left or Kevin on the left? Now you see, Kevin wrote 30 more than Sarah. So Kevin is more. More is on the right side. Very good job, everybody. So Kevin is more. Sarah is less. Okay, and don't forget, in this type of question, other than listing out who is more, who is less, please also label the difference. Okay, so Kevin is 30 more than Sarah. Next, James wrote 40 more letters than Sarah. So this time, James is also more than Sarah, but it's 40 more. It's a bigger gap, right? Just like the erasers just now, right? It's a bigger gap, so we do it to the right further. And you know, Sarah and James, the difference is 40. So you label it like that. Okay, and from there, you know, okay, the difference between Kevin and James is 10 as well. Okay, now with this information given, you can draw the model. Okay, now please pay attention to the live stream. Okay, don't talk to each other in chat. Okay, so when we draw the bars, here is a little tip to make your bar model more neat. Please draw the bars in the order from shortest to longest, like a staircase. Okay, so Sarah has the shortest because it's the least, followed by Kevin, followed by James. Okay, and now we are going to label the difference and the sum. Right, first of all, to label the difference, please draw a dotted line. Okay, and then we know that Kevin is 30 more than Sarah, right? Kevin, we compare with Sarah. When we draw out the difference, we tend to compare it with the shortest bar. So you see, Kevin and Sarah, I'm comparing this difference. Later, James and Sarah, I'm also comparing this difference. So this difference between Kevin and Sarah is 30. Now, what is the difference between James and Sarah? It will be James and Sarah. It will be 40. Right? James is 40 more than Sarah. The question also says that. So it's a 40. Right? And whoops, spoilers. Okay? Now we just label the difference. what is the other thing that we need to label? Right? Come on. I know you know the answer, but please also engage with me, right? Interact with me. The next thing we need to label is the sum. Okay, what is the sum? What is the sum, guys? The sum is the total, right? Did you see the total in the question? Yes, okay, it is 160. It is the sum. So it's 160 over here. Now with the sum and with the difference, we can now calculate each person wrote how many letters. Okay, so look at these three parts, right? These three parts that I draw with triangles. Maybe I should change to a different color, right? Look at these three parts with triangles. Actually, after you cut off the difference line at here, the three bars or three parts on the left, they represent the same number. So let's first pick off all the extra parts, right? And find out how much is one of these triangles, right? So we have to kick off the extra part, remove the 30, also remove the 40, right? 160 minus 30 minus 40, which is 90. Now, does that mean that each of this triangle is 90? No, it is not. Hey, okay? So 90 is not one triangle. Pay attention, right? I see someone give me the wrong answer. 90 is after I take away the 30, after I take away the 40, the 90 is referring to the rest, which is 3 such triangles. Then how do I find one such triangle? 3 of the same parts is 90, so one part is 90 divided by 3 equals 30. So actually every of these parts is 30, 30, 30. All right, so now you found the value of one part or one unit. At this point, please calm down, read what the question is asking again. Right, the question is asking, what is the number of letters that Kevin wrote? Kevin wrote how many letters? So do I need to look for everybody? Well, you can, right, if you want to be complete and check your answer, right? Sometimes if you are very confident, okay, you should have to stop and check your answers in the meantime, right? But if the question is targeted for one person, remember to answer the correct person. Don't just say 30 is the answer, right? Don't just say, oh, I found 30, so 30 is the answer. Cannot. The question says, Kevin, give me the number of letters that Kevin has written. Kevin wrote how many letters? How many letters did Kevin wrote? Not 120. No, we established that one triangle is 30. So it is 30 for the triangle. Plus, remember, Kevin has 30 more letters according to the model. So 30 plus 30 is equal to 60, right? So that should be 60 letters that Kevin has written, right? And that is my answer. Okay, so here are the most important part, two things that I just noticed. Number one, compare with a magic arrow. Number two, make sure you know how to find the value of one unit, or in this case, one same part correctly. Don't just subtract, you need to divide at the end. Okay, and remember, answer what the question was. Okay. Now that is the first thing that Sasmo likes to test, right? When they give you multiple characters and they ask you to draw longer bar, shorter bar, right? So you use a magic arrow. Now, let me show you another thing that Sasmo likes to test on, right? Using a very funny example, right? So we have teacher Yongam. Hi, that's me. And teacher Liz, right? Hopefully you still remember him, right? He's a part of my story last week as well. Okay, so teacher Yonglam and teacher Liz went to buy cupcakes, right? Teacher Yonglam bought 1, 2, 3, 4, 5, 6 cupcakes. Teacher Liz bought 2 cupcakes. Now, can you tell me what is the difference of the cupcakes that we bought? What is the difference that we bought? Very easy, right? 6 minus 2 is 4. Our difference of the cupcakes is 4. Now, we decided to each buy one more cupcake, right? Teacher Yonglam bought a new cupcake. Teacher Liz bought a new cupcake. Now, what is our difference at this point? He bought a new one. I also bought a new one. But then the difference, right? How many more did I buy? The difference is still 4. Now, what if I buy 3 more cupcakes, right? Teacher Yonglam bought 3 more, and Teacher Liz also bought 3 more. Did our difference change? Oh, it didn't change, right? Okay, by the way, the magic arrow is just used so that you can compare multiple quantities, arrange them in order, who is more, who is less, right? Okay, now back to this cupcake story. I bought one more. Teacher Liz bought one more. What do you notice? Teacher Yonglam and Teacher Liz is always buying the same number together, right? I buy one, he buy one. I buy three, he buy three, right? So you notice that the difference is always four. Right, I buy one more, he buy one more. The difference now is still 4. Right, now Teacher Yonglam bought so many cupcakes, he started eating them, right? Teacher Yonglam is very hungry. So Teacher Yonglam ate one cupcake. But at the same time, did you notice? Teacher Liz also ate one cupcake. I eat one, he eat one. The difference is still 4. Right, the difference is still 4. Now, I eat one, he eat one. The difference is still 4. I eat one, he eat one. The difference, you guessed it, it's still 4. Right? I eat one, he eat one. Well, at this point, you might be bored. You realize that when we increase or decrease by the same number together, did our difference change? Yes or no? Yes or no? Yes or no? Yeah, no, right? The difference did not change. But I eat one, he eat one. You see the difference still didn't change. I eat one, he eat one. I eat one, he eat one. We always increase or decrease by the same number at the same time. How many I eat, that's how many he eats. How many I buy, that's how many he buys. The difference will never ever change. All right, so that is the key point here. If I increase or decrease by the same number, the difference will never change. With that, let's try to solve this question in topic 27. Okay, let's see if you see any keywords here. Okay, read the question. Claw machine A has 31 stuffed toys. Claw machine B has 43 stuffed toys. I wonder why they give you the numbers at the start. Okay, after one day, now pay attention. After one day, an equal number of stuffed toys from each claw machine were won. That means if I win 5 toys from A, I also win 5 toys from B. I take away 5 from A, I take away 5 from B. If I take away 7 from A, I will also take away 7 from B. The number that decrease at each claw machine is the same, and no toys were replenished during the day. That means I did not put back any new toys. All I do is take out, and I take up the same number. Hopefully you see the trick here. All right. Now at this point, the number of remaining stuffed toys in A was half the number of stuffed toys left in B at the end of the day. A is half of B. Now this question is a bit weird, but I wonder, do you know how to draw the bar model here? Like A was half of B. What is the total number of remaining stuffed toys in both machines? Okay, so do you see the multiple relationship here? Actually, the multiple relationship is not that obvious. Yeah, kinda. But let's try to think about it. A was half of B. This half is actually the multiple relationship that I'm talking about. All right, so A is half of B. That means if I draw the model, right, B and A, who is the one unit? Who is the one unit? Who has less? A has less, right? A is half of B. A has less. Let's draw one box for A. But if I draw one box for A, how many boxes do I draw for B? 2 boxes, right? So the A is half of B. So this is a multiple relationship in a fractional form. So when I say A is half of B, basically B is double of A. Now that's a multiple relationship, okay? Good, everyone very active. But then, do you know the difference or do you know the sum? What do you know? Right. So I only give you that. Claw machine A has 31, B has 43. But I tell you, I take away the same number from each machine. If I take away the same number, did the difference actually change? Did the difference actually change? I take away the same number, just like how me and teacher Liz ate the same number of muffins. Well, you will realize that since we increase or decrease, in this case, decrease by the same number at the same time, the difference will never ever change. That means the difference at the end is the same as the difference at first. What is the difference? What is the difference? It's the same as the difference at the start, right? So it's 43 minus 31, which is 12. So that means the difference over here, right? The extra part in B is 12. B has 12 more at first. B will also have 12 more at the end. Now I'm asking you the total number. How many units is 12? 12 is equal to how many units? 1 unit, correct, very good. 1 unit is 12. In the total, there are how many units? Or you can count them one by one also can. At the end of the day, how many units are there in total? There are 1, 2, 3 units. So can you find out the answer? 3 units is equal to? 3 units is equal to? Whoa, very good job. Right, 12 times 3 or 3 times 12. It is equal to 36. So my answer is 8. Okay, no, the answer is not that number. Okay, right, so the answer is A, 36. Okay, the key point here is you see the question. An equal number was taken away or was won from each claw machine, and nothing was replenished, nothing was filled. That means the same increase, same decrease, right? In this case, it's the same decrease. So when I decrease by the same number, the difference between the two claw machines will not change, right? I eat 5, you eat 5. Difference will not change. All right, so this is a use case of this trick. You will see it in your practice paper. Hopefully you can identify it, okay? Okay, now this time there are 2 bags of fruits, right? There are 3 oranges, 2 lemons. Can you tell me what is the total number of fruits? The next trick, we start from counting fruits, right? How many fruits are there in total? How many fruits in total? It is, that's right, 3 plus 2 is equal to 5. Okay, so you know how to do addition like this, huh? Hopefully you do. Okay, you should. Now I move 2 oranges to bag B. Okay, from bag A, I take out 2 oranges and I give it to bag B. Now what is the total? I give oranges to the other bag. What is our total now? It's still 5, right? It's still 5. I didn't change. Now I throw 1 lemon from B to A. I give a lemon to A. Did the total change? No, the total also didn't change, right? What is Teacher Yonglam doing? Teacher Yonglam is just transferring fruits between the bags A and B. I'm giving the fruits between the 2 bags. In this case, we call this an internal transfer. You give me, I give you. You give me, I give you. Did I throw anything away? Nothing. Did I bring anything new in? No. I just give each other. In this case, the total or the sum will not change. All right. So with that, let's see how this is being used. Whenever you see a question where it involves giving each other only, the sum will not change. Okay, the question here is from topic 28, question 5. Okay, stop spamming the chat. Right, listen carefully. Eddie had 85 books. Ivy had 115 books. Eddie decided to give Ivy some books. Eddie gave Ivy some books. So now Ivy has 4 times as many books as Eddie. Did they throw away the books? No. Did they get any new books? No. What did they do? They just gave each other books. And in the end, they are asking, right, how many books do Eddie and Ivy have respectively? Okay, so do you see the multiple relationship here? Right. First, do you see the multiple relationship here? Can we draw a model for this question? If there is a multiple relationship, yeah, we can find the model to draw. Now you see a multiple relationship here, right? It says 4 times. So when you see a multiple relationship, maybe you can draw the model, but you need the sum or the difference, right? It's okay. Let's draw out the model first. We have 2 people, Ivy and Eddie, right? Can you tell me who is the one you need? Is Ivy the 1 unit or Eddie the 1 unit? That's right. Eddie is the 1 unit, right? Ivy has 4 times as many books as Eddie. Eddie is less. Eddie is my 1 unit. And Ivy has 4 times. So it's 1, 2, 3, 4. 4 units. Okay? Now the question is, do they have 85 and 115 here? Does that mean this is 115, this is 85? No, right? Because when is the 4 times happening? It's happening at now. Now means after giving the books. After Eddie gave Ivy the books, Ivy now has 4 units, Eddie now has 1 unit. Right. So I cannot say this is 115, this is 85. But then what other information can we label? Right, should I label the sum or label the difference? Everyone, please type in your chat. Give me your ideas. Do I label the sum or the difference? Okay, the hint here is Eddie gave Ivy some books. I only give the books to each other. Do I use the sum or the difference? Now, if you typed sum or total in the chat, good job, you are correct, right? Because I said just now, when I am giving to each other, right? I give you, you give me. I give you, you give me. It's an internal transfer, so the sum will not change, right? The sum will not change. The total will still be the same. So what is the total here? Right, the total didn't change. So can we find the total? Which information gives us the total? Yes, right. It says that there are 85 for Eddie at first, 115 for Ivy at first. So the sum didn't change. So I can still use these two numbers to find the total, which is 85 plus 115 equals 200. So that means the total at first is 200. The total at last is also 200 because internal transfer, the sum will never change. Okay. Now that we know the sum is 200, can you find 1 unit? Of course you can, right? But at this point, please be very careful because some of you will say, haha, I know 4 unit equals to 200. Is 4 unit equals to 200? Is it 4 units though? How many units are there in the total? There's actually 1, 2, 3, 4, 5. 5 units that is equal to 200. So then 1 unit is equal to 200 divided by 5, which is equal to 40. Okay. So now that you know 1 unit is 40, right? 40, 40, 40, 40, 40. Chill, calm down, read the question. What is the question asking? It is asking, in the end, how many books do Eddie and Ivy each have, respectively? In the end means after giving, at the end of the story, after giving. So how do you find after giving how many they have? You just look at the model. Right, Ivy at the end has 4 units. 4 units, every unit is a 40. 4 times 40 is 160. And then Eddie will have 40 because it's 1 unit. And with that, we have gotten our answer. Okay, read the question properly. Sometimes the question might ask, how many books did Eddie give? Right, so you cannot stop here. You have to subtract before and after. So read the question properly. What is it asking? Okay. Whew. So that's for sum, difference, and multiple, right? And we are just halfway through, by the way. We still have 3 more questions. Hopefully we can finish it in time. Okay, so this is the 3 core tips that I want to share with you about normal, sum, difference, multiple. But what type of situation do we often see this appear as well? It's actually age problems, right? So we are going to look at the properties of ages together, right? So let's see. So let me tell you a little secret. Teacher Yonglam is only 10 years old. Haha. If you believe it, you believe it. Okay. So let's say that Teacher Yonglam is 10 years old this year. And Teacher Liz is 8 years old this year. So then, how do I find our ages 1 year ago? 1 year ago, I just minus 1 to my age, right? 1 year ago, I'm 9. Another year ago, so 2 years ago, from 10, 2 years ago, 8. So then 1 year later, I am 10 plus 1 equals 11. Likewise, right, teacher list is 8 years old this year, believe it or not. Okay, so 1 year ago, again, minus 1, teacher list was 7 years old. 2 years ago, he was 6 years old. 1 year later, 1 year later, right, from this year 8, next year he will be 9 years old. Okay, so now we have filled up our ages, right? Very easy. You should know how to do it. Pay attention to the next two rows. First, the difference. Okay, do you notice anything about our age difference? Okay, so this year, what is our age difference? 10 minus 8, difference, minus, our age difference is 2. Last year, 9 minus 7, 2. Last year, right, 2 years ago, 8 minus 6, 2. 1 year later, 2. Hey, what do you notice? You notice that our difference of ages will always remain the same, right? The age difference between two people is always the same. That's because when I grow older, teacher list will also grow older. We grow older together, so our age difference will not change. Then let's pay attention to the sum. What do you notice about the sum? Right, every year we grow 1 year older. Does that mean the sum is also plus 1, plus 1, plus 1? Okay, so let's quickly label. What's our age sum this year? This year, I'm 10, he's 8. Our age sum is 18. 1 year ago, 9 plus 7, our sum is 16. 2 years ago, 8 plus 6, our sum is 14. 1 year later, 11 plus 9, 20. So do you notice anything? Every year, our sum plus 2 plus 2. But I thought 1 year passed only. Why is it plus 2? That's because, right, that's because you notice that, hey, plus 2 plus 2 plus 2. It comes from every year. Teacher Yong Lam grows 1 year older. Teacher Liz also grows 1 year older. So every year, my age plus 1, teacher Liz's age plus 1. So altogether, our age will plus 2. So every year, our age will plus 2 because we have 2 people. Every year, our age sum increases by 2 because there are 2 people. 1 year, 2 people plus 2. So then if there are 2 years, then 2 plus 2 is 4. That's why when we are finding the age sum, right, not only do you need to notice how many years have passed, you also need to be careful how many people we are talking about. Okay, so with that, let's look at another property, right? So let me say that teacher Yonglam is 2 years, it's 8 years old 2 years ago. 2 years ago, I was 8 years old. So 1 year ago, I'm 9 years old. This year, I am 10 years old. Teacher Liz, 2 years ago, he was 2 years old. 1 year ago, he is 3 years old. This year, he is 4 years old. Now, is there any multiple relationship between our ages? Let's see. 8 is equal to what times 2? How many times is my age compared to his age? 8 is equal to 2 times 4, right? So our multiple relationship is a 4 times relationship. Then in the next year, 9 and 3, right? Then you see, oh, 9 divided by 3, just now is 8 divided by 2. What? 9 divided by 3 is 3. This time, suddenly it becomes 3 times. Then when it comes to this year, 10 divided by 4, you will see, there's no multiple relationship at all. It's not even a whole number multiple relationship, right? 10 cannot be divided by 4. You can say 2.5 lah, but it's fine. It's not the whole number. So let's observe. Will the multiple relationship ever repeat? Can I say this year is 4 times, next year is also 4 times? Cannot, right? The key point here is an age multiple relationship will only appear once. So when you see a multiple relationship, it is only restricted to that year only. Okay, which is why, especially in age problems, the age multiple is more important. When you see an age multiple relationship, always focus on it first. All right. Okay, so age multiple is the most important. With that, let's take a look at some practice problems, right? For example, question 4 on your handouts. Okay, let's go. So the keyword here is the sum of a father's age and his son's age is 60. Did they mention when is it? This sentence, there's a bit nuance to it, right? I didn't say is it this year or next year or 3 years ago, but if you see the word is, it means the age sum now is 60. Now their age is 60. Then the next keyword says, right, the father's age was 3 times his son's age 8 years ago. So you can see here, there is a multiple relationship. There's a multiple relationship. So you see, we have the sum, we have the multiple. Should I start by thinking about the sum or start by thinking about the multiple? Should I draw the model based on the sum and the multiple? Guess and check, we can guess and check, but if the numbers get super, super big, or if they are super, super weird, right, it might be a bit hard to do guess and check. Okay, so we will use a bar model to do it. I gave you the sum, I gave you the multiple, so we can draw a model, sum and multiple. And we always start from the multiple relationship. So there's a 3 times here. So let's draw a 3 times relationship first. But does that mean now the age is 3 times? Can I just be like, oh, I know 3 times, 1 time, the sum is 60. Yay, can I? No, because the 3 times relationship is only at 8 years ago. 8 years ago, 3 times. Does that mean now is also 3 times? No, it's not. Remember, I said the age multiple relationship only appears once. The age multiple relationship only appears once. So when did the age multiple relationship happen? It happens 8 years ago. Right. So when we label our model, we must label it 8 years ago. So 8 years ago, we can see that the father and the son has a multiple relationship. Now, obviously, the son is younger, right? 3 times his son. So son is 1 unit, right? Father is 3 times, so 3 units. Okay. And then since the question gives you the sum, yeah, that means you can label the sum. Okay. So the question is sum and multiple. So we can label the multiple. We labeled it out in the model already. We draw it out. Then the sum. Haha, is it 60? Hey, they gave you the sum is 60 what? So does that mean the sum is 60 here? No, right? That's why a tip that I want to mention again is in an age problem with some difference in multiple, please remember to label the model. What is the timing that you are drawing this model for? Is this relationship now or 8 years ago? After you label it, you will always remind yourself, whatever I label here should refer to the timing given by the model. Now we know that the age multiple happens 8 years ago, but 60 is the sum now. So I need to find the sum 8 years ago, starting from 60. So let's look at 8 years ago. People, does that mean the sum 8 years ago is 60 minus 8 equals 52? Who thinks it's correct? 52. Yay! Now to 8 years ago, I just minus 8 lah. Right? 60 minus 8, 52. Is that correct? Can I just minus 8 1 time? The answer is no, right? Because think about it. What happens 8 years ago? What happened 8 years ago? 8 years ago, did the father become younger? Yes, the father becomes younger. He becomes younger by 8 years. So his age will minus 8, right? His age will minus 8. So there is 1 copy of minus 8. But does that mean the son did not get younger? Huh? Only the father gets younger. Ah? Only the father gets younger. No lah, okay? The son will also get younger. 8 years ago, father is younger by 8 years. Son will also be younger by 8 years. So then 60 minus 8 minus 8. That is the actual sum 8 years ago. And if you can calculate, you know that the sum is 44. The sum here is 44. So 4 units is equal to 44. So with that, you can find out what is 1 unit. 1 unit is 11. Right, 1 unit is 11. Okay. So am I done yet? No lah. So you can label this 1 unit is 11. Each unit is 11. But now, what is the question asking? The question is asking, how old are they now? Right? How old are they now? Is it enough to only look at the model and calculate, wow, 11, 11, 11, 11? No, because look back at the timing. The timing of the model is 8 years ago. So you will need to find out the age now, starting from 8 years ago. So let's see. Right now, father is how old? Now, can I only say that it's 3 times 11? Can I only say 3 times 11? No, because this 3 times 11 is the age 8 years ago. Right now, I want to find their age now. From 8 years ago back to now, the father should be 8 years older. So don't forget to plus 8. Then 3 times 11 plus 8. The actual age of the father is 41. Then the son, same thing. 8 years ago, the son is 11 years old. Back to now, right? 8 years ago to now, the son is 8 years older. So 11 plus 8, it is 19, right? And with that, you have completed the question, right? You can also check, okay, 41 and 19, is the sum 60? 41 plus 19, it is 60. So you have completed the question correctly. All right, so that is the first question for each problem. Remember the age sum property, right? Two people, they grow old together. So when you change the age sum, don't forget to consider that, right? Father is younger, son is also younger. Father is older, son is also older. All right, now with that, let's take a look at the next question, right? Similar thing, it's also an age problem. I tell you, Mrs. Lim is 41 years old and her daughter is 14 years old. How many years ago was Mrs. Lim 4 times as old as her daughter? I'm asking how many years ago, right? Was Mrs. Lim 4 times as old as her daughter? Do you see a multiple relationship here? Do you see a multiple? Of course you do, right? Mrs. Lim was 4 times as old as her daughter. This is a multiple relationship, right? So then okay, so I can label the model. But remember just now I said to label the model, we need to first figure out the timing for that model. Do you know when was the age 4 times for Mrs. Lim compared to her daughter? Do you know when was the age relationship 4 times? No, right. I'm asking you how many years ago it is. If you don't know, it's okay. You just label it a few years ago. Okay? Some years ago, you don't know, you want to find it, right? So you want to find how many years ago is it? Okay, so then label the multiple relationship, right? Mrs. Lim and her daughter. Daughter is 1 unit. Mrs. Lim is 4 times. So 4 units. And now here's the $1,000,000 question. Do you label the sum or do you label the difference? Do you know the sum or do you know the difference? Right. Do you know the sum or the difference? Can I just find the sum? I mean, you can try to find the sum. You know that their sum is 41 plus 14 this year, right? Again, this year, their sum is 55. But do you know their sum a few years ago? Can you even find their sum a few years ago? You don't know how many years ago was it, right? Is it 1 year ago, 10 years ago, 15 years ago? You never know. So you cannot work backwards to find the sum, right? The sum is not useful here. But do you know the difference between them? Okay, so you know that the age difference between them is 41 minus 14 equals 27 years old. Now, right? Now, currently, their age difference is 27. Will the age difference ever change? Does that mean 10 years ago, the age difference is different? 20 years later, the age difference is different? No, right? If you know their age difference now, then the age difference will be the same for ever, right? But maybe it's years later, years ago, it's always the same. The age difference between two people will never change. So you know that a few years ago, regardless how many years ago it is, the difference is still 27, right? 41 minus 14 equals 27. You know that difference now, then a few years ago, the difference is still 27. And now you realize, A, the difference here is 3 units. The difference here is 3 units. So 3 units is equal to 27. Okay? 3 units is equal to 27. So what is the value of 1 unit? 1 unit will be 27 divided by 3 equals 9. Okay? Right. So 1 unit is equal to 9. That means a few years ago, the daughter is 9 years old. And Mr. Slim is 9,999. 9 times 4, 36. Okay. Does that mean the answer is 9 though? Now you found 1 unit. Remember what teacher Yonam said. After you find 1 unit, can you just answer, oh, the answer is 9? No, right? I see so many YouTube comments have already reminded me, right? Read the question. The question says, how many years ago was it? I'm not asking how old was her daughter. I knew it's 9 years old. The daughter was 9 years old. But how many years ago is it? When do I start counting now? Do you know their ages now? Yes, you do, right? You know that the daughter is 14 years old now. And we know that a few years ago, she's 9 years old. We want to go back from 14 to 9. So that will be 14 minus 9 equals 5 years ago. Right, that's right. So the answer is 5 years ago. Please read the question carefully, right? And do not spam in the chat. Okay, listen carefully. Okay. So with that, that is a difference and multiple question. Okay, now your handout has one last question. Let's go through it together and then we will end it today. All right. So let's take a look at the next question. Now the question here says, Jessica's age, right? Jessica's age is twice as Derek's age now. Immediately, there's a multiple relationship, right? Jessica is twice of Derek. So you know Derek is 1 unit, Jessica is 2 units. If Jessica's age 8 years ago, let me underline with a different color. Jessica's age 8 years ago is equal to Derek's age 6 years from now. How old is Jessica now? You just as the timing is now. We know it's 2 times, right? And I give you this weird piece of information. Now, what does this mean? Right? Whenever you see this type of question, they are actually hinting at the difference. Right? Jessica's age 8 years ago is equal to Derek's age 6 years from now. To really understand this, we will find the age difference with a magic arrow. Right? So let's draw out a magic arrow again. Previously, right, in the sum and difference problem, left side is less, right side is more. Right? Usually the right side is the side that we indicate as the part with more. So similarly here, I will use the right side to label an older or greater age, and the younger age is on the left. Now, can anyone answer me? Is Jessica younger or the Derek younger? Is Jessica younger or Derek younger? Who is younger? Read the question. Okay, the question already said Jessica's age is twice as Derek. Okay, Eli, don't spam emojis. I'm looking at you. Okay, so Derek is younger, right? So Derek is here and Jessica is here. Now I told you Jessica's age 8 years ago is equal to Derek's age 6 years from now. So let's see how their ages will change, right? So here we say Jessica's age 8 years ago. 8 years ago, Jessica is younger. So Jessica, go back 8 years. Does that mean it's here? Does that mean, oh, I draw like this? No, right? Because at the same time, Derek's age 6 years from now, Derek's age will need to move bigger. So in this case, Jessica's age 8 years ago. Let me just go back. This is 8. I go back by 8 years. Jessica, go back by 8 years because it's 8 years ago. How about Derek? Does Derek go back or go forward? Derek goes forward for 6 years. And their age is the same, right? Because they are equal. Jessica go backward 8. Derek go forward 6. Then now they are at the same age. Now, using this picture, can you find out their age difference? Jessica, go back 8. Derek, go forward 6. And then now their age is the same. So what is their original difference? Their original difference will be 6 plus 8 equals 14. So the original difference is 14 years old. Jessica is 14 years older than Derek. Now you know their age difference. So we are going to label the model, right? So remember, in the model, we first start with their multiple relationship. Okay, Derek is 1 unit. Jessica is 2 units because I said Jessica is twice as Derek. So Derek is 1 unit. Jessica is 2 units. All right. And then I am going to label the difference. The difference is 14. Okay, because I already told you, right? The difference here is 14. Jessica is 14 years older than Derek. So in that case, hey, just nice. The difference here is 1 unit. So then 1 unit is equal to 14. And the question is asking how old is Jessica now? How old is Jessica now? Jessica is 2 units, right? I know 1 unit is 14. So the other unit is 14 as well. So the age is 14 times 2 equals 28, right? Jessica's age is 28 now. Now, of course, since the question is very complicated, once you know their age, Jessica is 18, Derek is 14. You can check if the ages make sense. Okay, Jessica's age 8 years ago, 28 minus 8. Derek's age 6 years from now, 14 plus 6. Is it the same? Is it this? If it is, then you are doing it correctly. All right. So with that, that is the final question in the handouts. Right. Thank you so much for staying throughout the entire duration. Hopefully you have learned a lot. Don't worry if you couldn't catch anything. I'll send the notes later. The playback is available as well. Right. Most importantly, here are the tips that I've shared with you today. Right. These 6 key points. Please remember them hard and carry them into your Sasmo preparation. Okay, I'll send this into the group chat later as well. All right. So with that, please remember to complete your practice and submit your answers via the link. Right, I've extended the deadline to 21st January because I know that some of you might be busy, right, throughout the entire week. Okay, and don't forget, we shall meet again in next Thursday, 4 to 5 p.m. for the next lesson. Right, next lesson, I'll go through some counting tips. Right, how do you count efficiently using addition and multiplication principles? Okay, with that, I shall see you next Thursday. Goodbye. Okay. Thank you so much. Yeah, Dora. Thank you. Okay. Bye, everyone. See you next time. Yeah, you're supposed to end. Yes, we are ending now. Okay. Goodbye, everyone. All right, I'm done. Okay, see you next week. See you next week. Goodbye. Okay.